This time in the example, we're not only going to create the new function, but we're going to evaluate it at a certain domain. So this time we're not finding the domain because we're given the domain of 5. So I want to find what f plus g would be at 5. So it'd be like I was finding the output at 5 and the output at 5 and adding them together. So I want to find the output of 5 at f and the output at 5 at g. We could write this out, but I would imagine most of you will do this in your head. So I'm going to put 5 in place of the x in the f function. 5 squared is 25, subtract 3 is 22. And I want to add the output at g of 5. So I'm going to put 5 in for x here, and I get 11. So if I wanted to find the new function at 5, it would be 33. Okay, let's find f minus g at negative 1. So I'm going to find f at negative 1 and subtract g at negative 1. So I'm going to go put negative 1 in for x in the f function. Negative 1 squared is 1. Subtract 3 is negative 2. Subtract g of negative 1. So when I put negative 1 in here, I get negative 2 plus 1, which is negative 1. Negative 2 subtract negative 1 becomes plus a positive. So h of negative 1 is negative 1. So if I graphed the f function and I graphed the g function and I subtracted the two output values at negative 1, this is what I would get. Okay, last one. Let's find f times g of 2. So I'm going to find f of 2 and multiply by g of 2. So I'm going to put 2 into the f function, so that would be 4 minus 3, which is 1, times g at 2 would be 5, and 1 times 5 is 5. So the new function at 2 is 5.